Kubernetes Admission Controllers from scratch, on film, in Python. I'm Steve Giguere. This is Matt Johnson over here. If anything goes wrong, look at this guy. He's going to be going along. We also have a dashboard that allows us to remote log into you. I don't think we're going to need to do that because the crowd's pretty manageable. I was asked to plug this. Next week, next Wednesday, I am one of the organizers of the DevSecOps London Gathering meetup that happens once a month, third Wednesday. It's our 6th birthday next week on Wednesday. If you can go to dsolg.com, come along. There's like free giveaways, prizes. If you attend, you can win a free ticket to Portugal in October. All sort of most expenses paid, let's say. If you go a little bit nuts, not on us. But free flight, free hotel, free conference. Not too bad, right? If you're into security. Check it out. Basically, you already know the requirements. A laptop, you've already got a Kubernetes cluster. If you've gone into that link, excellent. Basic knowledge of Python, not a lot of knowledge of Python, but just basic is required. Basic knowledge of kubectl, you've already got our instruct invitation. And just letting you know, you entered your name and email. We don't use it for anything. It's just so we can keep track of who's doing well. You've already got that? Everyone's got this, right? You guys are all logged in? I can check. Hold on. Yep. Awesome. Perfect. Okay. You know what an admission controller is? Hands up. Anyone who doesn't know what it is already? All right. All right. For the back.
Wait, what was the question?
I asked it both positive and negative, so there's no right answer. An admission controller intercepts requests to the Kubernetes API before the persistence of an object to make sure it's okay to become persistent. We're going to be talking about validating admission controllers. They are the last line of defense in terms of security. I come from a security background, so does my colleague Matt. There are many misconfigurations we can check for in terms of both manifests, vulnerabilities. There's a lot we can do with an admission controller to make sure that you're not allowing it to be persistent. I like to think of it as the bouncer at the door. The bouncer at the door of your favorite club is not looking for you in detail, just making sure you got the right trainers, you look okay, off you go. Looking for the low-hanging fruit of just complete disaster. Hold on. Are you coming in here, sir? Sir at the door on the phone. Got kind of a Jesus vibe going on there.
Hi.
You in?
No worries. Come on in.
Do you want to follow along?
Yes.
2 seconds. Boom, boom. How fast can you do that?
Wait, do I need a laptop for it?
Kinda, but you don't have to because I'm going to do it. You can just watch.
Yeah, I don't have a laptop, but I can. Yeah.
Perfect. Then you're a spectator. That's just totally fine. All right. There's multiple types of admission controllers that are called dynamic admission controllers. The validating one is just as I said. It's validating anything before it becomes persistent in a Kubernetes cluster. That's a long-winded way of saying it. If we reject it, it doesn't become persistent, and you have to learn a lesson about what you've just done and stand in the naughty corner. The other type is called the mutating admission webhook, not used in this workshop. It allows you to intercept something, modify it, mutate it, and then if you have validating admission controller, it passes it on afterwards to the validating admission controller. It is possible to coordinate or design your Kubernetes cluster in a way that you create mutations that then get blocked by your validation. Bad idea. Personally, I think mutating admission controllers are a terrible concept because it creates an automatic version of drift. If I'm going to send something into my cluster and I mutate what then becomes in runtime, that means I don't actually know what's in runtime. I'm not using a GitOps approach. What's in my manifest is not what's running. So I think there are some edge cases where mutating is good, but mostly I try to avoid them if I can. Basic anatomy, API handler, authentication, mutating admission controller, as I said, validation, validating, and then persistence within etcd is the general anatomy of the way things become persistent within our cluster. Our admission controller is written in Python. A lot of it's been done for you because I'm not here to teach you how to create a API microservice in Python. A lot of it's done using, well, Gunicorn, Python. That's all been a Flash application. The basics of that are already going to be there for you. I will be showing you what to add to create the validation option, and we'll be exploring the schema that gets sent to you as part of part of the admission controller, part of the validating aspect of it. Because the problem I had, and this is a product of having to write an admission controller for our own product, I'm wearing the t-shirt, based on a infrastructure as code scanning tool called Chekhov. I was asked to write an admission controller. I said, okay. So I can pack that up into a container, but I had no idea what I was going to be sent. And seeing the schema, I was a little bit like, okay. I went looking for information on how to write one, and there's really hardly anything out there. Hence, this was designed. One of the tools we're going to be using in addition to this, and this is the only thing you take out of this, which it won't be, but if it is, ttl.sh, I don't know, hands up if you've ever heard of this? No hands? Awesome. It's a zero authentication registry that you can use at a temporary element to build a container, send it out there, draw it back into your cluster, and then within, say, in this example, see the 1H on the tag? Within 1 hour, it destroys that container from the registry. So it's great for demos. So if you're ever doing a demo that involves building containers, pushing it to a registry and pulling it somewhere and you don't want to have credentials involved, perfect. We're using it. What we don't cover in this very quickly is I'm not getting into the CEL Common Expression Language, which is now only in beta. It was in alpha as of like a month ago, and now it's in beta. It sort of works. It's going to be cool when it's done. It would be a disaster to try and demo it now, so we're not doing that. There'll be a V2 of this whole thing using CEL probably next year. We're not going to talk about Python, Flask-based applications. You do not require deep knowledge of Kubernetes manifests, and I'm not going to go into challenging you like earlier if you were in David Flanagan's raw code where you have to know kubectl and the anatomy of Kubernetes generally. You don't need to do that. There'll be 6 chapters. You've probably already seen that, and you've already got this. So I'm going to jump over, and I'm going to run into this right away. And the first thing you need to do, if you've already done it, is just click Start to play the track. Are you doing that? Oh, cool, perfect. And my all right. This is not me, so if it goes horribly wrong, this is Matt. Matt's going to click Start. Now, the first chapter is really only so you can get familiar with the environment. What we have is a Kubernetes shell. Do something in Kubernetes shell. Echo hello? You could have done kubectl get pods. Right, nothing on default namespace. Great. Very basics deployed. If you don't know, the instruct VM uses K3s, so if you're into it, it's very fast to boot. Kubernetes derivative. Yeah, thanks for blowing that up, I was going to say. There are instructions down the side that are in incredible detail. I tend to be a little bit overly verbose when making tutorials. I am going to talk through them. What we're doing here is we're just getting familiar with the fact that we have the shell. We also have the code editor, if you don't mind going to the code editor, Matt. Now the repo has already been cloned. You can see we've got AC manifest, images, and utilities that help us through the process. This exists, if you don't mind me jumping away from you there, Matt, for a second. Here. This is, I don't know if you can see that. This is my GitHub repo. My GitHub name is Eurogig. It's called Eurogig because when I moved here, there was going to be a gig that I was going to do in Europe. I was going to do in Europe. I was only going to stay for a year. It's been 24 years. I'm still here. I don't know why. It's no longer a gig. It's a permanent residency. And then AC Workshop is where it lives. And the solutions are there under .solutions. Now, obviously, you can't see them if you just ls, but they are there. Anytime you want, if you want to click chapters or skip things, and you click the skip button within instruct, the solutions get applied, and you can jump ahead if you need to do that. So if you're looking for anything in terms of how to create a very basic admission controller, you could skip to the end solution, and you've got a Python program sitting there and a manifest that deploys a reasonably fundamental admission controller out of the box, and you can start building from there if you want. Given that we have limited time, it's 4:16. We're going to try and get this done in 30 minutes. It may be a challenge, but let's move onwards and upwards. All right, back to the Kubernetes shell. The first thing I want you to do, and by the way, the slides, you'll see there's a thing called intro slides. Anything that's in the intro slides, it's there. It's just a link to a read-only version of the slides I just showed you. If you click it, it's going to launch a new tab. Did you do that already?
I did, but I'm not signing to Google.
Oh, right, fine. Never mind. So all I really want you to do is pad a few things out. If you look down the side, this is a weird way of doing this with me instructing you, but you know what to do on the side. Roll down the instructions. We haven't created a namespace for admission controller yet, so go to the top. First thing we're going to do is just create a namespace with, see that's not currently there. We need to create one called AC Workspace. workshop, sorry. So I've given you the code there. You can copy that and go into the code editor. And there already is a file, but there's nothing in it. Now the reason I'm doing this is because it drives me a little bit nuts when people just do, oh, create namespace. It's like you're not doing infrastructure as code properly. I'm a big fan of GitOps, and even just never just creating a namespace all willy-nilly. Just make sure you create the namespace file, put it into Git, make sure it's permanent and reproducible. That's the first thing we're going to do. The next thing you need to learn when you're using code server as a service like this is that that little dot on the tab next to the name means you haven't saved it yet. So you got to do a Apple S or Control S. There we go. And it goes away. If you've done that, the biggest problem we've had in the past with this workshop is people forget to do that. And they deploy and they go, nothing happened. It's like, go back, the dot is there. Cool. So we've looked at the code editor. We've looked at the shell. You roll down. It's a very short section. You should be able to roll down and just do a apply of that. Now you'll notice that I'm being really super thorough. You don't have to highlight, Matt.
I know. No matter how many times we use this interface where you can literally just touch this little copy to clipboard thing here.
Yeah.
I'm old school and always forget and always end up doing that.
And do it.
Just click this little button.
Yeah, and you miss one character. So go back to the Kubernetes shell. Anytime you need to switch directories, I include the CD. It's so brain dead you don't even have to know what directory you're supposed to be in. So that should just apply and create the namespace. And you should be able to also then verify with another get namespaces. Cool, we have AC workshop. So that's just the basics. It's pretty idiot-proof, the first one. You get a little bit of a positive affirmation by clicking check. There's an automated script in the background, so if you click check now, it should say, yeah, I can see a namespace called AC workshop. You're permitted to move on, and it will automatically do that to the next step. When things get a little bit progressively worse in terms of the amount of technological thingies that we need to do. Pardon me. Click start. So now we're going to start looking at the Python application that's involved. There's a lot of text there, again, but I've already said it, explaining what an admission controller is. This workshop is also designed to be done offline, but it takes like 2.5, 3 hours to do it offline because you're not reading all this. I'm going to tell you everything you need to know. What we're building is this, like, I think I say no frills there, very no frills. But once you've got that, the amount of power you have to really start filtering on what you can deploy is pretty strong. So a little bit of information at the start. We'll roll down and start enabling our admission controller. So expand the next section. And there is a file called admissioncontroller.py in our code editor. So hit on that. And it's in the image because it's part of our image we're going to build in. So this is basically a boring, does-nothing Python Flask application in a way as a microservice. You can see it, between the hashtags I've said, put your validating code in here. And that's what we're going to do. The first thing we're going to do is we're going to give you a little bit of a hint as to what the schema for what you get sent looks like. The first thing is to grab the UID of the request. And we're going to pop it in there. Now you can already see that the request has a UID. So what's coming in from Kubernetes is giving us an ID that is unique to that particular request. I sometimes use the UID to create files, particularly in terms of debugging. Because if a request comes in and you mishandle it and you don't know what it looked like, you'll see later that in the manifest I'm mounting an empty dir as a temp file, which I can wipe away as a read-only area where I can put these files and go, okay, what went wrong there? And then eventually I'll just remove that. But in the short term, when you're designing something in Kubernetes, it's hard to debug if you don't know what it is that went wrong. So that's the first thing I'm doing. Then immediately afterwards, we can grab that next piece of code. And then I'm going to use JSON dumps to convert that to JSON, and you can see I'm saving it to a file. Marked by the UID in my temp, my only writable directory /temp. And that's another little security tip. My entire container is mounted as read-only. Really great to fend off attackers or crypto miners or anybody who's trying to run anything nasty in my container. Should I've done something wrong security-wise, always use read-only and then save one. I would even say don't call it temp because it's too predictable. But for the purposes of this, I'm calling it temp. If you're ever going to do a one read-only directory, call it something weird that only you know, that people can't figure out. Another important safety tip. So that doesn't look too bad. You can see you've already done the last piece. The reason I'm by default saying result equals false is what happens anyway is that I need result to equal something. False means we'll block everything. It's also a great way to determine that your admission control actually works, because that means everything you try and push in your cluster, you'll get an error from your admission controller saying, okay, I'm not going to let this go. Great little bit of verification. So we've done that. Have you hit Control S or no, you have not? Most common mistake in these things, there we go. We've saved it out. We're going to roll down, and Matt is going to build our admission controller. But he can't build it without a Docker container, can he? Damn. All right. We do have a Docker file there in AC image. You can see it over on the right side. And once again, I've given you nothing. So we're going to grab all of this Docker container, and we're going to have a little talk through on it. All right, cool. So we're using Python as a basic because I'm writing all my code in Python, so that helps. I'm doing a basic update and install a Python pip so I can add a few extra requirements that are required for this. All of my requirements should be hard-coded, not just all willy-nilly any version whatsoever, particularly when you're doing demos, as well as for security, because you don't want your demo to break like it did last night for me when I was trying to make it work and I spent the entire night fixing this exact tutorial. Don't do what I do. So I'm installing everything, and then you can see I'm copying my admission controller into my app. I'm putting in front of it my Giguere. Now, worth noting on that line there, the very bottom line, you see I've got a cert file and I've got a key file. This is so I can communicate via an encrypted method to my Kubernetes API. So that is there, and yet those don't exist yet. So I'm building this under a grand assumption that I've got my key file and my cert, which I don't have, but we're going to have to make those. So they're there. I see the directory they need to be in /certs. Kind of been doing a bit of chicken before the egg, but nevertheless, this is what we've got now. So we're going to save that out, Matt. Perfect. You can see after every step, if you're doing this manual, I say, don't forget to save. And I go through and explain in detail every single piece of this. You're going to have access to this for the next while. Like, I don't shut the environment down. So if you ever want to go back and take a read or what's in here, then you can learn about what all of these little components are and why they're there. So we're going to roll down. And I want you to run an env grep myid in your Kubernetes shell. All of you should have a different myid. If you don't, that's really bad. Things aren't going to work. But it should be absolutely fine. This will be unique to Matt, and that means all of you can use ttl.sh and not push over each other in terms of the Docker container that you built. All right, let's roll on down and let's build the container that we just did. And I've got my CD there, pushes you into the AC image directory, and we're going to build. Now, paste it, but don't hit enter. Nice. So you can see because the myid has already been stored as an environment variable, I'm going to do a docker build-t ttl.sh, which means when we push, it's going to go to that ephemeral registry, and it's going to put myid for 2 hours. So this is going to be persistent for 2 hours in that registry. So if you hit enter, thankfully this is Instruct is a reasonably good VM system.
Might be worth mentioning what ttl.sh is if you haven't come across it.
I did it. It was in my presentation.
Sweet.
Yeah. Don't worry about the red things. It doesn't like when you run pip as root, so it's going to flash up a bit of red. Sometimes we break the rules. I do change the Docker container away. Actually, if you go back to the Docker container for a second, you'll see I do switch the user to app later, which means I'm not leaving the container running as root, which is puts me in the naughty corner if I do that. But I am doing some things in advance of that I needed to be root for, so it's going to run. The first one's going to take a little bit longer to build, just because it's the first time we're building it. As you know, with Docker containers, it will be only building the Delta after the fact. But it only takes about, 30 seconds to a minute, and we're done. And then finally, we're going to push that up to our ttl.sh, and we should be pretty good. So roll down a little bit further. We have a summary of what we did. Now I need that to be persistent in TTL because a little check looks to make sure that the thing you just built is actually sitting in the registry and we're good to go. So now essentially we built the simplest admission controller ever. All it's going to do is grab the request, put it in a file, report false, and we're good to go. Now we haven't made the manifest yet. We're going to do that in the next step. So as soon as that is pushed, you should be able to hit check. Don't be impatient. Wait for it. And we'll build a manifest around this that'll get it running. All right, so if you click check, it should be happy with you and give you a little bit of candy. I'm going to go over here and see who actually is following along. Oh, look at that. Oh, some people have gone ahead. I love it. All right, next challenge is loading. We should have brought some swag, as prizes for who finishes first. I know. All right. We're going to generate a TLS certificate. We're going to generate a Kubernetes secret. We're going to do a lot of geeky things here. All right. We're going to look at the admission configuration.yaml as the first thing we're going to go to. It's in AC manifest. Now, the reason this one is populated as opposed to some of the other ones is because there isn't an easy way to just generate an admission configuration. I don't know if you're familiar with kubectl or you've done like the CKA exams or anything. It is within your interest to know how to generate manifests via kubectl super fast. But you can't generate this one. You have to find examples. You've got to close your eyes and grab in the dark to make it happen, which is why I had to populate this one myself with a few exceptions. So let's roll down a little bit. You can read about it in the Kubernetes documentation. I'm going through here, and just in the nature of time, I'm not going to go through what all of these things mean, but failure policy, for example, meaning fail means if for some reason it's gone, it doesn't let anything in. It's your good security default. It fails with the door closed. Timeout is set to 30 seconds. The default, if you don't include timeout, is 5 seconds. So if you're doing any validation in your admission controller and it takes more than 5 seconds, I would always bump it up to 30 to start and then pull it back so that you can have a better timeout on there. I'm not going to talk about side effects. Is a weird parameter that got put in Kubernetes ages ago. I don't know anybody that uses it, but we're not going to remove it just in case for legacy purposes. The namespace selector. Now, if you paid close attention when we did the namespace, there was a label in there that was called acworkshop.ignore. The reason that's there is so that our admission controller doesn't shut down our admission controller. I would highly recommend adding the exact same label to kubesystem, or kube anything, or kube whatever. Because the lesson I learned when creating this, and Matt knows this very well, is that I didn't originally have this label across all, I would say, infrastructure-sensitive namespaces in our own environment and in other customer environments, and I accidentally paralyzed a few Kubernetes clusters when things were trying to restart and we kept blocking them. So be very careful when you're creating an admission controller that you label all of the certain namespaces you want to ignore as ignore and add this as part of your namespace selector within your admission configuration. Absolutely mission critical. If you look at some of the other more commercial, not commercial, but open source ones like Gatekeeper or Kyverno, the list of exceptions they have is considerable because they've learned their lesson. We had to do research in a previous job on Rancher or OpenShift and work out what are all the namespaces that may be absolutely mission critical that you don't want to block. So having a nice whitelist there is really important. Okay, after that, I'm looking for resources which are deployments, pods, or replica sets, anything that might instantiate something new. And then down below, I'm looking at create or update, because even if I do an edit, I still want the validating admission controller to fire, even if I'm not doing an apply of something new. So create or update is exactly what I'm after in there. Now, the thing that's missing down at line 27 is the config, which is where am I applying this? What name, what namespace, what path? Now, I haven't quite got all of that. I know my namespace is going to be AC Workshop, which is fine. I can fill it in now if I wanted to. I know the name of the API path I want to use, which is my admission controller.py is /validate. So I could fill it in now. And the name of it is going to be validate. I haven't created the service yet. But I know in advance I'm going to do that. So I also need CA bundle. I haven't created any of that. So these are the requirements we have to do now. We have to create a service, and we have to create our CA bundle. So the first thing we're going to do, we're going to CD in our Kate shell to our AC manifests. Now, if you do an ls there, Matt, just for the purposes of, there is a service there, but it's not complete. What we're going to do is we're just going to write over it. So cut and paste that. and this is another straight out of your Kubernetes exams, how to create manifests. We're going to create a service with cluster IP. We're going to call it validate, which we just wrote into that file. We're going to do a dry run client. We're going to give it the right ports in the namespace AC workshop. We're going to output it to YAML, and we're going to pipe that YAML to service.yaml and overwrite the basic one that we've got already. So if you do a cat of that or look at it in code editor, either one, or both. Cool. So that kind of aligns with what we just changed in our admission configuration file. So that should be good. Now we haven't actually put it in place. We're not going to do that quite yet. There's a little bit of a, we were talking about this just before we ran the workshop with some Kubernetes enthusiasts, which is pretty much everybody here. When you deploy the admission controller, you have to do everything in exactly the right order as well. Otherwise, you could shoot yourself in the foot. So roll down to our next step. Creating our TLS certs. Now, rather than teach you how to do this, I created a bit of a utility, but we'll take a look at what's there, which is another reason why you might like the repo that I've got in GitHub. So you can do, we're going to run get cert, but you can do a cat on it if you want to see what's inside it. So we've created the webhook. We're not going to run that. Cool. But at least it shows you what, this is what's running on the inside. The important thing about this, when you're creating the certs, is that you have the DNS correct, like you're using the right domain. And because you know Kubernetes generates a domain, you can see that I've got all the things that are related to my service are there. So Matt, if you just highlight the last validate.acworkshop.service, right, that's the important bit. If you don't have that when you create your cert, it won't work. So that's an important little piece of the puzzle that we have to get. And sometimes if you go off and try and do this on your own, this is a huge stumbling block if you screw this up. It feels like you did everything right and nothing's talking. Okay, so we have our certs. We're going to create a secret that we're going to mount inside our deployment. Cool. Hit enter on that. And you can see I'm just taking the file webhook key and webhook cert, doing another dry run, piping that to AC manifest secret. If you want to do a cat of AC manifest or .ac manifest. Cool. So then we have our secret, we have our service, we're almost there. We have to do one more thing. So do a run of the other utility, cert64, and that will convert into base64, which is what we need for our manifest, and we're going to add that into our deployment. So roll that and securing our YAML. Now remember where we were in our client config service, within our admission configuration, go back to code editor. Just go back to code editor. Admission configuration. Perfect. CA bundle. Just put the cursor there. Now go back to your Kate shell, dot that one, don't copy, that's a demonstration. Grab the second one. And paste it at CA bundle. You could just do, yeah, see, now you're crossing. All right, nice work. I would use V works. All right. So that should essentially be everything we need to make this happen. Remember to hit save. Save. All right. We're almost there. Installing the admission controller in our Kubernetes cluster. Open the deployment YAML. Now this won't be 100% correct. There's one thing critical that's missing. If you go down to image, you see it has your unique ID. Now if you don't remember what your ID is, you're going to have to echo your my ID again. And put that into your manifest. Ooh, there we go. Nice. Give it a save. Now, I'm going to scroll down a little bit on the instructions. There is a lot of me talking about all the different elements of the manifest. If you do a generation of a manifest using kubectl, create deployment, -- image, nginx, you get something that looks a little like what we got here. It does a very simple manifest, wildly insecure from a basics perspective. There's no security context, nothing saying read-only, there's no seccomp, None of the things you would want are in there. And there's no instructions really in terms of Kubernetes I/O to tell you the right thing to do to make that happen. So if we roll down a little bit, you'll see that I've got relatively comprehensive instructions here on why you should do what you should do, why you should have a security context, why you should use a read-only file system, why you should allow privilege escalation to be false. I mean, the basis of that is like even tools like ping have privilege escalation built into them. There's a lot of innocuous commands within Linux that have something inside them that could be exploited. So making sure that's set is absolutely mission critical. Now we're also going to do a few steps here. See if Matt gets these right. No pressure. We're going to add our empty dir temp, which we already promised would be there for admission controller. And we're going to add it. Wait, is this after temp? No, empty is already there, right?
Yeah.
All right, roll down. After temp, we're going to add our certs volume. So not that, is that one? Yeah. My indenting, good. My indenting should be correct if you are at the beginning. You can save that. And then after the other attempt, the volume mount. So roll down a little bit more, copy that, certs volume. And after, there we go, right after that, perfect. Yep, you know it's correct. The other thing we get wrong is indenting. That's a very popular mistake. So save that. You've already done the MyID, so you're sorted. Okay, so save that out if you haven't done it already. I know we're moving pretty fast. And then deploy. So go on to the next section. Everything should be done. There should be nothing missing. Let's go into our util. I should cd in. I'm going to ask Matt to do a cat on setup.sh so you can see why I made it into a script. So I'm deploying in the order the secret. So the secret's there. Why? Because we need the secret to, otherwise the deployment complains. The service, then the deployment, and then the admission controller. In that order, because that's the order of dependency between all these different Kubernetes objects. That's what has to happen. So if we did everything right, we should be able to run setup.sh, and everything should go. Ooh. Cool. So if yours just did that, amazing. You now have a running admission controller that should block everything you ever try and put into this cluster. Not ideal. Nevertheless, it's working, and we can mess with it afterwards. So if Matt clicks check, it should verify the admission controller is running. It may fail just because the image isn't pulled yet. So just do a little bit of a watch on the pods and make sure that you can just keep doing that. I have a tendency to do a dash A, yeah, there we go. And just
It succeeded and moved on.
Oh, great. Perfect. Yeah, because the pod needs a moment to get started. All right. Now we're just going to verify it's working and make a very simple change to it. Okay, so now I want you to cd into test cases, and you'll probably notice in here, cat the nginx.yaml, and pretty much exactly the one that was earlier in the documentation is there. This is a generated nginx with 2 replicas, and it's using nginx latest. This is exactly what you get if you go to Kubernetes I/O and you cut and paste the first example from deployment. This is exactly it. All right, well, if we're working, try to apply that into our cluster and make it persistent. And if you're successful, you should see a message saying AC Workshop found the object in violation of our admission policy. Why? Because we said result equals false. So everything is going to bomb. But that's good. It means that we have a successful communication. The object is being passed in, it's being passed to an admission controller, it's being told to fail, it's being rejected, and we're getting an informative message back. We're 90% of the way there. We just don't have any real rules. Now, it's pretty easy to create a rule, because as you can see, a very obvious, terrible thing to do in a deployment is to use the tag latest. If you're using latest, you actually have no idea what container you're using. If there's been a malicious attack on Nginx, unlikely, but nevertheless, whatever it is they upload is going to be latest. And suddenly you're using that in your cluster. Also a bad move is to, and this is more common, is say if I did Nginx 1.23.3. I think that's the one I use here. Still bad to use the tag, because tags are not unique. I can push 1,000 images into the same tag over and over again and change the image that is there for that tag. These are not unique. What we want to use this as SHA. So let's add a policy. Let's add something around that. But in the meantime, we need to know where the tag exists. So we're going to review what the schema looks like, and we already know it's there. So let's use kubectl exec to take a look at what the schema looks like very quick. And I'm trying to make this as easy as possible. So I'm saving the running pod name as pod name. You could echo pod name if you want to. Perfect. Next. Use that pod name to see that there's a file. Perfect. That's the file with our UID of the last request. So now the next time we're going to save that. Well, you can copy it, or you can do what I did. I'm going to save that as my UID. So I'm running the same command, but I'm just going to store it. And then I'm going to exec. You see what I'm going to do? I'm going to cat that file. Now I'll do the next one because it's a little tidier. Because I already installed JQ on this, we can put it into pretty colors. Or if I really want to, actually go to the next one. I think I get a little bit pedantic here. I push it into a file called request.json. So if you've got a code editor. Oh, is code editor not working? Why is code editor not working? All right, well, we can evade this. It's already there. You can scroll up and see it. So you roll up. No, what about that's not working? Okay, I'll have to talk to instruct about that one. Then we can break down the basics of where our image actually lives. Now, if we want to check for image latest, I think you went too far. Too enthusiastic. Keep going. That's the metadata. There's a point where which all of the information about the request goes away, and then we get to the actual, something that looks a lot more like our original manifest. There we go. There's our image, Nginx latest. So what we want to do is break down the JSON. This can be a bit of a problem. If code editor actually was working right now, which is weird, when you look at JSON, now if you notice this, the top bar in code editor shows you the path. So if I'm clicked on Nginx latest, I don't know why it's not working. Very strange. Shows you the path to where you need. So it's actually very easy to translate that into a request info and grab the information you need for a check. And we'll see that when we look at our how to find it. We'll see that when we look at it later. So we're already there. Removing the schema. Oh. Oh, I see. We've already done that. We're going to improve our error message. Right, so around volume 36, which we can't see at the moment, but that was where the Nginx deployment was. So you're going to have to manually edit admission controller.py. How's your Vi?
Is anyone else struggling with the code engine view, or is it working? It's not opening on this page.
What the? All right, well, we're going to go rogue here. So manually edit. Well, now we're testing your. No, there's no AC. The path is there. AC image. Oh, so go to AC workshop. I can ad hoc this. AC image. And vi admission controller.py. Cool. Roll down to UID equals request info. Go to the next line, or hit O. Cool. Move down the instructions. I wouldn't do the indent. I probably auto did the indent. I'm going to grab a little bit more information there. Cut and paste that below. Now all I'm doing here is validating that I've interpreted my schema right. So now you can see that I'm going request object kind and request object metadata. I'm verifying that the actual object I've been sent that's been wrapped in a validating request is actually under the tag object. And from there on in, I basically got the same manifest that I submitted, so I'm now just verifying the path is correct. I'm storing Kate's object as kind object name, and if I'm right, then if you roll down, you don't need to change anything after this. Just roll down to the error message. And you'll see I've already got Kate's object in this error message. A cheat, I already added it when you went to the next thing. So you should just be able to save that out. And one more little change we need to do in our manifest. Roll down again. We have to rebuild. So I'm asking you to build, but I'm tagging it differently now, so you can copy all of it. You can just copy the lot. It'll all just work. Nope. Do that. And all you need now before you actually reapply is go to the manifest and change the 2 to a 1. So we aren't writing over our original just to prove it's a different image, and also so that Kubernetes will download it, because if I say the same tag, it will just go, I got this. So we're going to change the 2 to a 1 to make sure that Kubernetes installs the new admission controller in there. So that's under AC manifest, deployment, and I just search for 2H. There you go, change that 2 to a 1. Save that out. And if we're good, you can cut and paste that thing down below, which is the CD, which are already there. It doesn't really matter. Not going to change the difference. Okay, now you just do a kubectl get pods. You can even do a -a-w. Ooh, we got to separate those. And you should see the pod cycle through, which is hard to look at. So it says running, terminating, running. Cool. So the new one's running. So you can Control-C out of that. And go back to the, there, just cut and paste that right there. Go back and try and deploy our test case again. Okay, cool. We got a bit more information now. So we validated that we've interpreted our schema correctly. Deployment, Nginx deployment is what we were doing, and it was in validation of the process. You should be able to click check and move on. I figured this could be done in exactly an hour.
We're doing all right.
We're doing okay.
Sweet.
Start. Is Coder not working again? What is broken? It's probably use SaaS solutions. It works, it works, it works, it doesn't work. Same thing in every section. Okay, cool. If you've never used Instruct before, you provision all of your everything like at the very beginning. Nothing changes afterwards, so I don't know why it suddenly doesn't work. But okay. Now the downside about our manifest is that we are using the latest tag. And really we should be using something a bit more constant. So the best practice would be if we roll down on the instructions there, Matt, is that we use something with a SHA, which is a slightly different format if you're not familiar. I'm sure a lot of you are. We're going to add a rule that's going to look to make sure we aren't using latest, but more specifically, making sure that we're using a SHA. So we can see around, if we look at code editor doesn't work, if we look at in test cases, and we can just skip to AC manifest, or we can look at request JSON. We can see that we're using the latest tag. You probably don't have to look at it. You can just take my word for it. But you'll see if you just search on the word latest. Even there you can see it in the metadata. Yeah, you can't have that. That's a really bad thing. So we can create a very simple rule that says don't ever allow latest. Even if you did that on its own, it's a very fast check and it works really well. So we're going to open up our admissioncontroller.py, which is an AC image. And we're going to have to add a little bit more checks. Now, so I've provided the code again. Rolling down a little bit, I tell you exactly what to do. So it's always within those hashtags. Now roll down a little bit. Replace the exactly where you are, result equals false, with a slightly larger, oh, you rebel, you're going below end of code. There we go. All right, good boy.
Should look a lot nicer in code, but you get the gist.
Okay.
Cool. Save that.
So now we're checking. Hold on. You can always save it, sure. If you can see there, what I'm doing rather than looking for latest or a negative latest is I'm looking for that @ sign that indicates within the image that there's actually a SHA being used. It's the only time that would ever happen. I'm stealing this check from, well, in the open source tool checkout we worked on, we have a rule that checks for this, and we do it via looking for the @ sign. And it's pretty straightforward. It's the exact same check that we do there. So if that looks correct, it should say true if it has digest, false if otherwise. We have a more advanced check now. Roll down a little bit and make sure that in the other instructions, make sure there's no further instructions. Yep. Okay, so we're going to save that. And we got to do the usual rebuild, redeploy. I think I changed it to 30 seconds now. Now there's one step after this I can see we aren't going to have time to do where we actually add checkoff to the container. And checkoff has this 1,000 rules for Kubernetes. So it actually takes a giant leap in terms of manually checking. You could start leveraging, you could leverage that. You could leverage any Kubernetes open source tool you want and now drop it into this admission controller and make it configurable. And suddenly you've expanded your admission controller to have way more rules than you could possibly comprehend. And it works pretty well. We're not going to do that bit because it's a shameless plug of the open source tool that we work on, but you get the idea and the lesson will still be there for you.
And if you do have a Kubernetes cluster you want to try that on, just Google checkov Kubernetes Admission Controller, and you can even configure using a config map
Yeah.
a subset of the 1,000 policies. So you can say, actually, it's an admission controller. I only care about absolutely blocking like most critical issues like containers running through and things like that.
Rather than the 1,000 rules, yeah. The admission controller we eventually wrote only has like 17 rules, probably-ish, of the whatever huge amount of things that could go wrong. Okay, so have you changed that to 30 minutes? All right, save it out. And you should, if you're pushed, be able to redeploy. Almost, 5 seconds. And the last thing we're going to do is we're just going to change our nginx.yaml, add the SHA, and we should see it successfully deploy and bypass the security. And that is the last thing. So that's going to be done by the time we're ready. Fixing our manifest. Now I provide you, yeah, so I would just go into that directory. So it's going to fail. Now go into your test cases, do a vi of nginx. Well, you're already there, so I think you're okay. Via nginx, go down to where the image is. You have to search for that? All right, so, all right, and then down below I have a SHA. So I'm giving it to you so you don't have to go look it up. You could just grab the whole line, actually, good point. Just go down one line. Oh, now you messed your indenting. Undo. Just hit O, or that. I think you can see that's the SHA for 1.23.3. There's the at, so we're good. So if you save that out, try your redeploy, which I think you just did and it failed. And it worked. So we've created a rule, we've fixed our security issue, and we deployed into our, so now we have a functioning admission controller. And we did that in under an hour, which is I think pretty cool. If you don't mind doing it at ls-al, go to the top level above AC Workshop.
I think the admission controller config, by the way, is wrong on that because it's matching on pods, but the JSON path you set in the Python file is looking for /template, which will only be deployments of replica sets.
Oh, do I have a?
Actually, if you check the admission controller pod,
Yeah.
I think it's failing on creating the actual pods.
Do you think it is?
Yeah, because I can't see them there. It did for me anyway.
Okay, check it out. Check it for you. Yours, Matt.
I might be talking about that. But
Did you?
Yeah, let me have a look at deployments. Hang on. So the nginx deployment is there with 0.2. Yeah, that's correct.
Oh, so I have a bug?
But at the same time, it wouldn't have let you deploy the deployment. But yes, we do have a bug in the manifest.
So we have a bug in the manifest, but that's independent of the fact that we got past the admission controller. I will fix for the future version. That used to work. I must have done something stupid.
I'm going to go have a look.
All right. All right, it's 4:57. That's the end. Thanks for coming. It's been a sparse crowd, but nevertheless entertaining. Cheers. Enjoy the rest of your conference. And go get beer upstairs. I think it's serving in 30 minutes. Where was my bug?
This is just I need the test case done.